the inverse of a function. Suppose we are given a function of x. Recall that this one, whatever variable that will be in this function will be x, nothing more than x, because this is an explicit function. But if you intend getting the inverse, which is also denoted by this, always denoted by this, if you intend getting the inverse of this, that means we're going to express this function of x, we're going to express it in terms of y. What do I mean? Let me give you an example. If I have, for example, fx should be x plus 1. This is a function of x, right? And we also know that y is equals to fx. That means I can also say that this is equal to y. Then, which means also y is equals to x plus 1. Right? Good. Which means that if I want to get the inverse of this one, I'm going to express this question, I'm going to express it in terms of y. That means I'm going to make x subject of formula. And how do we do that? You subtract 1 from both sides. So I'm going to be having x is equal to y minus 1. So now, looking at this now, this is a function of y, because the only variable here is y, which means I can also rewrite this as f of y. So what we want to bring out is that the inverse function of x is equal to the function of y. Please note this, very, very important. If you want to understand this inverse, you have to know this, very important. That the inverse function of x is when you express that same function in terms of y. So let's get a simple example again. Let's get an example. If I have something like this, let's get an example. If I have, suppose we have function of fx to give you 2x plus 1 over x minus 3. You want to find the inverse function of this question. Very simple. You want to find the inverse of this. That means from this general form, we know that this our question is also equal to y. Then I can also write this as y is equal to 2x plus 1 over x minus 3. So let's make x subject of the formula. So from here you cross multiply. You cross multiply on both sides. So I have xy, y times x is xy, and y times 3 is minus 3y. Then 1 multiplied by all of this, we still have the all of this. Okay? So which means I'll have xy minus 2x is equal to 1 plus 3y. So I'll bring out my x since I want to make x subject of the formula. Okay? So I have this 1 plus 3y. Can you see that now? So I'll divide both sides by y minus 2. Y minus 2. Y minus 2. Which means this cancels this. So my x actually is equal to 1 plus 3y over y minus 2, which is also the same, saying that this is a function of y. So what does this mean? Our inverse function will now be, our inverse function will be f. Inverse function will now be, since we want to write it in terms of x now, being inverse will be 1 plus 3x over x minus 2. It's very simple. Once you just have a good knowledge of changing of subject of formula, you are good to go in this inverse. So just make sure you change it and you get your answer. Let's check onto the next one, so we can actually grab what this inverse is all about. Let's check this once. Suppose you have something like this. Suppose you have f, the function of x, is equal to 3x minus 2 over x plus 1. And you're also given g into 1 minus x to the squared. So, and you are required to get your g inverse in composition with fx. What we need to do is to first get our inverse of g. So how do we do that? We know that our g is 1 minus x squared, which is also equals to y. So we want to make g an inverse. That means x will be the subject of the formula. Doing that, we will have very simple arithmetic. This should come here to become positive, and this should go this way to become other ones, so they can stand alone. So I have my x squared to be equal to 1 minus y. Okay, so x is equal to the square root of 1 minus y. Therefore, the inverse of g, x, is equal to what? The root of 1 minus x. Very simple, right? Now, we need to still put this fx in the question. That means wherever I see x, I'm going to put fx. In conclusion to this question, we now have this x, fx equals to the root of 1 minus fx, because that x is occupying that. So therefore we have this roots of 1 minus, what's our fx? Our fx is the whole of this. So we now have what? 3x minus 2 over x plus 1. Okay, so to quickly get that, you can simplify. You can simplify that. So that will be, we have our square roots to be, so x plus 1 minus 3x minus 2 over x plus 1. Okay, so this, we have this. I'm going to have, open the bracket, I will have x plus 1 minus 3x plus 2 over x plus 1. Don't forget your square roots. Okay, very important to write it down. Okay, so in that case, I'm going to be having, for the final answer, g inverse of fx will now be the square roots of, this one and this one. They are like times. This one, 1 plus 2, that's 3. So I have 3 x minus 3, that's minus 2x over x plus 1. That answers that question. Now there's this particular question I want to show you guys. Very, very interesting questions. It needs you to really apply your basic arithmetic. Suppose you're asked to, you're given fx 2x plus 1, okay, is equal to x squared plus 3x minus 2, and you're asked to find the inverse function of that f to 2. Now you cannot just substitute that 2, because we still need to find the inverse. All right, so how do we get the inverse? First, we need to get the inverse of something, we need to get the f inverse of x first, before you can now find this, which means we need to get fx first. That means we need to equate this to become x. So how do we do that? We say that the x we want to do is equal to 2x plus 1. All right, so I want to get this particular x. So I'm going to be having x minus 1, because this one moves to the other hand, so I have minus 1 is equal to 2x. So the x we wanted to substitute for is equal to x minus 1 over 2. So this is what we're going to put in here, so we can now get our fx. That means I'm going to have f into x minus 1 over 2, representing this x. Don't forget we still have our 2 plus 1 is equal to x minus 1 over 2 squared plus 3 plus 3 plus 3, okay, plus 3 into x minus 1 over 2 minus 2. So this cancels this, truly this cancels this, so I'll be left with f into x minus 1 plus 1. That will be equal to, if I should expand this, I will have x to the squared minus 2x plus 1 over 2 plus 3x minus 3 over 2 minus 2. This square should affect this one, so I'll be having 4 here instead. And it's very obvious that minus 1 should cancel minus 1, so that means we have gotten our fx. So that means our fx now will be, fx will now be, let's find the LCM of all this. Our LCM for all this will be 4. So I have my 4 here. So x squared minus 2x plus 1 plus 2 in 4 is 2, that's 6x minus 6, then 4, that's minus 8 to get that. So fx is equal to x squared, like times of x, this and this, minus 2 plus 6, that is actually, that is 6, that is a plus 4, plus 4x minus 2 plus 6. Then there's another like term here that we can bring together, that is 1 minus 1 plus 1 minus 6, that is minus 5. So minus 5 minus 8, minus 5 minus 8, that is minus 13. Okay, so minus 13 over 4. So this is our fx that we need to get first before we can proceed to get our inverse, this fx. But that's not where we are going. We need to find the inverse of this. That means we are going to make this to be in terms of y. In terms of y. Quickly. Make this in terms of y. We have to write y is equals to x to the squared plus 4x minus 13 over 4. I have 4y, cross multiply, that's how I got my 4y, this over 1, cross multiply, so I have 4y, then having the next one to be x to the squared plus 4x minus 13. Good. Now we want to make x subject of formula here, so let's, and because our x is having a power of 2, we can apply our quadratic rule 2. So now I can rewrite this as x squared, right, plus 4x minus 13, bringing this 4y to the other end here, it becomes what, minus 4y, all equals to 0. So since I'm working in terms of x, you can now say that my y is a constant, right? It's a constant. Good. So since my y is a constant, let's use our basic knowledge of quadratic equation. And what is the quadratic equation? Quickly, quadratic equation is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So with what we are saying here, This is my A, this is my B, then the whole of these guys, they are my C. They are my C. So let's impute that one after the other. We have x is equal to minus b, which is 4, plus or minus the square root of b squared, which is 4, okay, minus 4 times 1 times the whole of this, minus 13 minus 4y over 2a, which is 2 times 1. Okay, that's 2 times 1. 2 times 1. So in that case, we need to still press further. Don't forget how I got it. This is my C. You know, I can still put a plus here to give me the whole of this. So it's still possible that way. So let's rub this off so that we can concentrate on the current position of our solvings. All right, so I have x is equal to minus 4 plus or minus the square root 16. 4 squared is 16. Now, minus 4 into minus 13 minus 4y times 4 times 1 is 4 over 2. 2 times 1 is 2. So x is equal to minus 4 plus or minus the square root 16. And let's open it carefully. Minus times minus here is plus, right? That's plus 4 times 13. That should give me 52. Okay, now we move to the next one. This one again, this times this is a plus, right? A plus. 4 times 4 is what? 4 times 4y here is 16y. That's 16y. Very easy to do. Over 2. Don't forget, we are just finding the inverse. We have not yet gotten what. So this question is very interesting. Very, very interesting question. Very interesting type. I really love the fact that it involves application of some basic knowledge. Okay, now we want to add this together because they are like terms, right? That is 68. So x again is equal to minus 4 plus or minus the square root of 68 plus 16y, okay, over 2. Hope it's clear now. Over 2. Good. So now we need to observe something very quickly. We need to observe something. There's something common in this I can still factorize. X is equal to minus 4 plus or minus. I can still bring out 4 out of these guys. So I have 17 plus 4y. Isn't it? Good. Over 2. So I have x equal to minus 4 plus or minus square root. The square root of 4 here is what? Is 2. So that 2 comes out. Then I'll be left with 17. 17 plus 4y over 2. Then we can know that this 2 here is 2. This 2 cancels this 2. So I'll be left with something like this. I'll be left with x is equal to minus 2 plus or minus the square root of 17 plus 4y, which means my f of y is, we know it's equal to inverse of x, right? And it's equal to what? Minus 2 plus or minus the square root of what? 17 plus 4x, because I'm now dealing with x, right? So this is our inverse. Very simple. So our inverse here. Now, since we've gotten our inverse as required, we still need to put 2 in our inverse. So therefore, inverse to 2, which means that anywhere I see x, I'll put 2 there. So I have minus 2 plus the square root of what? 17 plus 4 into 2. So that will be inverse of x to 2 minus 2 plus or minus square root 17 plus 8. Very simple. Very simple. Just steps. It looks long, but it's very simple. Alright. We have this 17 plus 8, that's 25. So this inverse of this to 2 will now be minus 2 plus root of 25. So just as we started, the root of 25 is 5. So I will be having minus 2 plus or minus what? 5. That means our inverse of the function, as we have 2, will be minus 2 plus 5, or what? Minus 2 minus 5. So my answers here should be 3 or minus 7. Therefore, this is equal to 3 or minus 7. Very simple.